Imagine that Bob is trying to plan the September schedule for our care center. He needs to ensure that there are going to be enough people on hand to handle the expected number of calls, and make sure that he has the right mix of people with the right set of skills. To start with, Bob could look at the average number of calls each month over the last 3 years. So he calculates the mean or average by taking the total number of calls and dividing it by the number of months. Bob gets back a number, let's call it X. But now it's time to get more curious and creative by questioning the answer. How trustworthy is X? Can Bob really use it to predict call volumes for September? To answer this, Bob decides to calculate the standard deviation. This will tell him how stable the prediction of X is going to be. Oh, it's not looking good for Bob. The standard deviation is quite high, which means call volumes fluctuate a lot from month to month. So now Bob knows his original X, which was the average number of calls per month, is likely not that trustworthy. Bob decides to go back to his original data and look at the mean or average of only the month he cares about, September. There is less data, but this number seems pretty stable. It won't have a high standard deviation. Okay, so with his most recent calculation, Bob knows approximately how many calls to expect in September, but he still doesn't know what the most common client issues are. Knowing this will help Bob select a team with the right skills. Bob turns to the call data and discovers that clients call in for a lot of different reasons. The good news is that these reasons are coded. For example, a call can be coded as a MasterCard inquiry. This is all nominal data though. It's categorical, not numerical. Bob decides to assign a number to each unique code and then determines mode for this data set. Now Bob knows which issue is expected to be the most common one in September and can assign team members as needed. Good job, Bob!